All right, we're working on question 2.4G. I've already made a drawing here. I think it might be easier for you guys to do the motion diagram this way, where you break it up into two separate subchapters, where A is on the way up and 1B is on the way down. Now that is 2 meters per second of your code, and all the rest of the stuff that you have here are kind of like the givens that we have in the back of our reference table. Final velocity at top, or the initial velocity on the way back down is equal to 0. The acceleration is like a 9.8 for both up and down, and the final velocity at landing is going to be equal in magnitude but opposite in symbol to, or opposite in sign to the initial velocity, so it's -2 on the way back down. Now, there's another way that you can do this. If you decide, you can actually choose to do it this way. This is kind of like a big picture view where you just have the initial velocity, the velocity at top, and the final velocity at landing. This way kind of doesn't break it up into subchapters. And I think that if you know how to do it this way, it might make it easier for you to do Unit 3. But I think most of you, if you want to know how to do it this way, you can come see me after school or for extra help. I'll go over that with you. But I think for right now, most of you will most likely go with this scenario. Now let's start off with the first question. We're trying to solve for how high does the object rise. So for part A, step number 1, you're solving for D of chapter 1A. Step 2, your givens are VI, VF, and acceleration. Step 3, best equation to use is VF squared equals VI squared plus 2AD. That's equal to 0 squared. This is equal to 2 squared. 2 times -9.8 D. Now, what I'll do is I'll square the 2, bring it over the equal sign, it becomes -4. Then we divide out the 2, we divide out the -9.8, and we get an answer about 0.204. Now, for part B, the question asks us for how long does it take for it to reach its highest point. So for part B, it's on a separate sheet. You're trying to figure out the time to the top, which is chapter 1A. Step 2, you have VI, VF, A, and D. Step 3, the best equation to use is VF equals VI plus AT. You have other options, but I think this one's the easiest. Step 4, it's equal to 0, it's equal to 2, -9.8 T. Step 5, we do 2. The 2 gets brought over the equal sign, becomes -2. Divide that by -9.81 or 9.8. So we have 0.204. Now for part C, how long does it take for the ball to reach the ground after it reaches its highest point? The answer for C is kind of easy. If you look back at this drawing here, the amount of time it takes to go up and the amount of time it takes to go back down is equal. So the time it takes to go from its highest point back down to the ground, same answer, 204. That'll be different for everybody depending on your code. Part D says what is the velocity when it reaches the level from which it started. We actually already established that in our drawing. If you look at the back of our reference table, that given is supplied to us, that the initial velocity and the final velocity on the way back down is equal in magnitude but opposite in sign. So the answer is actually -2.